Yeah, good afternoon, good morning, depending on which time zone you are in. Welcome, ladies and gentlemen, to today's Dallmeier webinar on multifocal sensor technology. What is actually the customer benefit? How does it work? And what's in it for me, basically? My name is Josef Braun. I'm responsible for product marketing here at Dallmeier, and what we want to cover today, you can see on this little agenda. A few words on who Dallmeier is for those of you who don't know us yet. Then what are the functional principles of the multifocal sensor technology? I will hopefully give you a better understanding on the functional or operational benefits with a few examples. Then a few considerations on the cost side, cost of ownership, and what does multifocal sensor technology mean for analytics. And then optional, because we will not cover the last point in the 25 minutes, is I'm going to show a few real world sequences to show you from some real examples how multifocal sensor technology works. So for those of you who have more than the 25 minutes, you're more than invited to stay a little bit more with me and get some real world footage. No worries, this will not be a 10-minute presentation on the greatness of Dallmeier as a company, but a few words I think are justified and important also to put the whole company and our solutions into context. I think the most important points that I'd like to make are in the first bullet point. First of all, 35 years. We are one of the, or actually the only video technology vendor that has been in the market for more than 3 decades, which has a few implications. First of all, of course, we can really look back and into a very deep experience in all sorts of industries, which we can, of course, have our customers benefit from when we are in the consulting level or stage of a project. And also in times like these, we've gone through more than one crisis, obviously, in those 35 years when it comes to financial stability and all those things. This is also, of course, very relevant for many, many customers out there for a reason. The second point here is the term called video information technology. What is that all about? Basically, we are at the brink or at the beginning of a very exciting area, technology-wise, where, as we all know, video technology, image capturing, and analytics technologies. First of all, of course, all the interesting and exciting and sometimes hyper-inflated technologies around artificial intelligence come into place, and there's no easier way, to quote our founder and CEO, Mr. Dallmeier, there's no easier and the more affordable way to get information out of complex contexts than a video image. So there's exciting stuff ahead on having those two technology elements going together. And the third one, I will have another slide on that, is made in Germany or made in Europe, as we may put it. But before I talk about that, a few more points here. One important point, Dallmeier is an innovator in the market. We are not a company that looks into existing technologies and then says, hey, we are going to refine this or provide a more affordable, cheaper solution. For that, rather the opposite. We are seeking for solutions for innovation that makes our customers' lives easier, that solve real customer problems, and that makes things easier, as our tagline is. And there's a few proof points that you can read here. The first digital video recorder with motion detection in 1992. That was a gasoline station, petrol station solution. And then 2011, most importantly for this call, the patent for our Panomera multifocal sensor technology, which is still unique in the market. We serve quite a number of industries. You can read them yourselves, 400 more employees worldwide. And to point a little bit out, or I'll point out a little bit more on the made in Germany or made in Europe point of view. About half a year ago, we were with a few sales colleagues and engineers at the first meeting at a very large energy provider here in Germany, first project meeting. And sitting together with those guys, the leadership team there, the security chief and so on, really the first question they asked us, what do you do for security, data security, and privacy? And can you prove it? Can you document what you do? And that is a very important point that we hear more and more often, privacy and security by design. Being a manufacturer in a country that is following the rule of law, and it is a democracy, and also having biggest part of our value creation here in Germany, where we can, really have a look at our software development, no backdoors in there. We have external companies doing penetration tests and all that. We think that we can claim that from a privacy and security perspective, we do the most we can, or you can do as a vendor. A few words on that. Presence in over 60 countries. And then before we go into multifocal sensor technology, one last slide on the company. What we hear very often from our customers is what they appreciate is that we are really a whole solution provider. We come from the recording technology. We have a extensive software platform for security and business application in place, from digital incident files to physical security information management solutions, for stadium video management systems, for specific solutions for logistics provider, for example. We provide a wide range of software solutions. We have the camera technology that we will talk about today. And then what is also worth to mention here is that we do a slightly different approach on the planning side. We have a whole team of 3D engineers in-house who create a digital twin of the customer's environments. And if it's a big World Championship stadium in Russia, 9 out of the 12 Soccer World Championship stadiums in Russia were actually equipped by Dallmeier. So we can save a lot of money actually already in the planning stage and create very high quality planning systems. And then we also have a wide range of consulting capabilities based on 35 years of experience. And we can also provide a lot of services if the customer wants that from our mothership, so to say. So with that, I would like to really start with the main topic of today, Panomera multifocal sensor technology. And I want to start with a few of the functional principles. If you look on the, what you see here is the latest and greatest models of our Panomera product range. On the right-hand side is the W series. It's a 360 degree camera, which I will show you later how it works. And then on the left side, this is the Panomera S series. And the first thing that comes to mind is, or what you can see is there's actually 8 lenses or 8 individual cameras in one system. And what do we do with those 8 different cameras or lenses? Each of those lenses has a different focal length. And depending on the use case, the Panomera S series is available in different models, depending on the angle that we cover. We can look into the distance, or we can cover a wide or large area, all the way to a runway Panomera system for airports, where I can cover multiple kilometers of runway with only 1 or 2 systems. Depending on the use case, we have the focal length of the sensors arranged differently. In this example, what you see here in front of you, we have 3 sensors covering the very back of the area. Then we have the number 4, and so this is number 1 to 3. We have number 4 and 5 covering that next level, and sensor number 6 and 7 covering the front area. And then there is an 8th sensor that covers the whole area again and creates kind of the overall layer. And doing that, we can make sure that we cover the entire area with a minimum resolution density. Now, what is that? If you look at the right-hand side, there is actually a DIN norm for that, which very clearly lays out what quality I can have, what image quality I can have or must have or need to have in a certain area. So there is detect, apologies for the German here, there is a detect, which is 25 pixel per meter or less, which basically means, well, I can see something is happening there. There is observe, that's the yellow one, 62.5 actually pixels per meter. I can observe things happening there, and then there's two more. This is identify or recognize, the blue one, and identify, the green one. Those are the two most relevant ones for city surveillance, for example. Whenever I need to, have faces recognized or identified for court use, for example. So 250 pixel per meter, that was for, or more, that was, for example, required by the stadia in Russia, or is a typical value that is required in safe city environments. That basically means that most likely, we know in video technology nothing is 100%, but most likely when I have video footage from some incident and I show this to the judge, and there is a suspect in front of the judge, if I have 250 pixels or more, it's very, very likely that the judge will say, yes, the guy that is sitting in front of me is the guy on the video. So this is more or less how the DIN norm sets those parameters into perspective. Observe, so 62.5 pixels or more is typically a value that helps us or is already sufficient if I want to do object classification, distinguish between a person, a car, a bicycle, or objects of that size. So that gives you a little bit of an idea what this is about. And then if you look at the same image from the side, let's say, what you can see in blue Panomera, those are the different focal lengths that I have as opposed to a single sensor camera. And at the end of the day, the benefit is pretty obvious. I can cover a large area with way less systems that than would be required with traditional approaches. And I can show this to you a little bit with some sort of a demo here, or interactive. Again, we have our DIN norm, this time in English: detect, observe, recognize, identify, and then different sensors cover different areas. This is the overview sensor, in this case with this Panomera model, also the one that covers the frontmost area here. And then I have sensors in the back that cover the far end situation there. So this is how you can imagine, or how I hopefully clearly demonstrate how the multifocal sensor technology works from the way it is set up. Now, what is the benefits of this technology? Let's start maybe with a little view on city. This is a piece of marketing. It's like a tabloid, yellow press tabloid that we came up with at some point to generate some awareness out there. I think it's justified to do some creative things in marketing, and it has a big provocative headline that says the camera manufacturer, actually what we want to do is sell as many cameras as possible, one would think, and we recommend fewer cameras. How does that work out? What you see here is the cathedral area in the city of Cologne in Germany. And as this is a worldwide call, I'm not sure everybody is familiar with Cologne and what happened there in the New Year's Eve 2015, although it's been really widespread. There was very nasty riots going on with a few thousand people. There was, rape, theft, violence. It was a very nasty situation. No need to go into details there. But at the end of the day, it turned out that they couldn't prosecute almost a single person because the video, the square was under video surveillance, but the quality of the videos was just so poor that they couldn't create any evidence out of that. So Cologne police went out and asked a number of camera manufacturers out there, including ourselves, to come up with a proposal of a solution how they could solve the problem and create a really good video surveillance for the Cologne Cathedral Square. And what you see here is in the magenta, the purple color, a competitive offering. Each of the yellow dots is a mounting point. And then on each of those mounting points, they would have had multiple single sensor cameras. Then on the right-hand side, the green one, this is the actual now input since 2016 in production Dallmeier environment. 2 mounting points, and one has 3 cameras, 3 Panomera systems on them, and the other one has 5. I think the 3 one is what you see on the front page of this tabloid. By the way, with the alternative solution, it would have also been necessary to mount a few cameras on the cathedral wall, which probably would have led to some funny discussions with the guys from the monument protection department. Anyway, we came up with this solution, and now I want to show you a little bit how this actually works out. So this is the 3D animation or model of the area. If you remember from the previous slides, here under those blue eyes, that is basically what we were looking at. And there's three cameras on this mounting point, and there's 5 cameras on that mounting point. As you can see, different models. Here it says top line S8, 115, 30. This is the degree number, and then also how many megapixel we technically create with the Panomera system. Now let's have a look into one of those camera systems. So first, let's try out a PD set system. What you do with a PD set, you zoom in, and we have actually quite a decent, quite a good resolution there. But as you can see on the left side very clearly, anything else except from your focus area is not recorded, and it can also not be observed in a live situation. So when you look at other use cases, like we are actually surveying the Oktoberfest, where we have also a very complex situation where many operators, many police people need to look into different areas or different corners of a complex situation. You don't see that with a PD set system, right? So let's see what happens when we switch to megapixel. Let's be fair and use a 4K animation, and there also you see the pixel density up there and the distance. So let's have a look here. The same lady again. Now we are at 81 meters. We have a pixel density of 41 pixels per meter. We are, from a DIN norm perspective, on the detect level, and basically, of course, you have a very low resolution because this is a big megapixel camera, and in the far distance with the digital zoom, you don't see enough. Now let's have a look what happens when you do the same thing with Panomera. Regardless of where you are, as you can see, we are always on 150 pixel or more, so recognize or identify in our DIN situation. And even in the far back, we are, 93 meters. We have a pixel density of 167 pixels per meter. I mean, this always depends on the customer requirements, and we have a very clear view on what's going on. And now also multiple number of operators could open up different windows here or different zoom areas. So you could have 10 operators looking at that crowd, at different people in that crowd, for example. And how do we do that? If you remember the previous slides, the yellow stuff here, the grids, they show the sensors, the different sensors that we have, and that's why we can have that resolution, the minimum resolution density across the entire area. Another way of looking at this is perimeter, or another example, same key value proposition with single sensor cameras. You need quite a number of cameras, obviously, to cover this perimeter. And with Panomera, because you have multiple focal lengths in the camera, you can really reduce the number of required systems dramatically. And also here, the same thing again. I have my perimeter situation. I use a PD set camera. Of course, I have a great resolution, can clearly read what's on that sign there, but I don't see the two guys anymore who throw a parcel across the fence. Same thing, megapixel camera. I go into the far back. Pixel density 39 pixels per meter, 76 meters distance. I can't read the sign anymore. And then with Panomera, I have both, the best of both worlds. I have the overall scene. I record everything. I can have multiple colleagues look into different areas of the entire scene, and I have the highest possible resolution density across the entire area there. And then, so those were the two outdoor options. Another thing that I want to show you quickly is a slightly different thing. This is the 360-degree Panomera system that you saw at the beginning. The example here is a casino interior, a gaming floor. I have one 360 camera, and there's another one, 4 in total. And then again, our color coding, 250 and 125 pixels per meter. And let's see what exactly the view is of one of those cameras. I can also open up my zoom window and then can zoom around and can really have a closer look what's going on in the right-hand window, or zoom in as with the other models in the casino environment. I also have an automatic mechanism that gives me the top table camera if I want. So as an additional view, what you see also here is, by the way, our casino automation technology. Where using artificial intelligence, we can measure anonymically values of chip stacks and so on. And the other thing I wanted to show here is when I go into a certain area and the system finds out, hey, there is another W8 360 camera where I cross the circle of the other camera, I will give you that automatically, and I can then zoom into the second camera, and that way can create really a great overview of complex environments. Again, indoor, another one is, you can imagine with the 360 version, typical use case is event halls or airport terminals, all those things where you have large interior areas, or also exterior parking lots, and use cases, applications like that. To give you an idea of the efficiency, one of our casino customers in Australia, they say usually it takes them 20 minutes to track down a person with, across different single sensor camera screens, and you have to look at different screens and so on, find the person. They brought that time down to 3 minutes with the Dallmeier W8 solution. So this is the efficiency perspective or part of a solution like that. Oopsie. So with that, I hope I gave you a good overview on the, let's say, functional benefits of the camera system. Definitely, I have a really superior optical control across complex situations, outside, inside, outdoors, indoors. I can have multiple users zoom in a overall scene at the same time in parallel. Everything is recorded, everything is visible. Still, this is also helpful in addition to whatever the police examples I gave for safe city applications. Think about an airport, the apron situation there. Typically, you have multiple stakeholders who are interested in optical control of that area. It's the apron, flight controllers, it's people who are observing, surveying the gasoline tanking situation and so on. And all of a sudden we have an alarm. There is the federal police coming, says everybody out of the way, this camera is ours. And then those aforementioned other stakeholders are literally blind. With Panomera, you just say, gentlemen, here is your workplace now, please feel free, use the camera, use whatever you need. And the other guys can continue their job and also have the areas available that they need to look after, right? Then, of course, the overall overview. I don't only want to see what's happening right now, a theft or any incident, any event. I want to see what happened before something happened. And then the more area I can cover with one single screen, one single recording, of course, the better my overview. I think this is pretty obvious. All that translates into much better operator efficiency and better reaching my objectives, my targets. And it also has a very strong economical advantage. And there's also implications for the big topic of analytics. And those are two latter points I want to elaborate a little bit more, even though I will not exactly hit my 25-minute target. For those of you who deal with public sector tenders, they know very well, typically it's not what the required solution is not the cheapest, but the most economical solution. So that's why it's very important to look at total cost of ownership and not on the question, how much is one of your cameras? A question that we still hear very often at trade fairs from customers, where we really need to help them understand better what is the actual situation out there. So first of all, infrastructure. If I have less cameras, I need less installation points, I need less cabling, I need less digging, less infrastructure, less labor cost, and so on. So this is definitely a big saving aspect already when it comes to infrastructure. Installation, of course, when I have less camera systems in total, I need less labor for installation, less time, less effort. Plus, there is what we don't have time in this webinar, but we will have an additional one. We have a very innovative, thought-through installation concept called Panomera, where you need only one Allen key, for example, for all the cameras, all the mounting elements. There's a system called Quick Lock, which allows you for one person only to quickly mount even the 13-kilogram Panomera cameras in a safely and efficient manner, and a few other things, starting with unpacking the system that give you a massive time saving in the installation process. And then operational efficiency. Of course, if I need less screens, I need fewer operators, or I can cover a much bigger area with the same amount of operators, and they will also be more attentive and have better results. And then also, which I will show in the optional appendix of the webinar, with artificial intelligence-based assistance system, I can even further increase the employee efficiency when it, for example, comes to perimeter protection. And then when we look at total cost of ownership calculation, well, the system cost might be a bit higher with Panomera than conventional technology, but already with the infrastructures, I save a lot of money. We had just not too long ago a big airline customer here who reported directly in a conversation, yeah, guys, this is true. I just had a look at my infrastructure offering from the competitive situation, and it was exactly, almost exactly 50% of the total cost, including the cameras, that actually the Dallmeier solution came up with at the end. Operating cost, I think I was hopefully able to give you an idea about how you save there. Productivity cost is a business administration term for cost that is saved or occurs when you have systems that are less efficient to operate than they might be when you have a better system. And then this is obviously what we can potentially save. And then I want to share a few thoughts on analytics. There is a basic coming from IT, database operations, programming, informatics, and so on, very basic theorem that basically says when you put, or the output of a data processing system can only be as good as the input of data you put in there. So quality in means quality out, garbage in means garbage out. And that means that the predictable pixel density, as we can do it with our multifocal sensor systems, you can directly translate into a predictable data quality that you need to run your analytics over a certain area. So if you have a very low resolution area in your image, well, you can't do good analytics because you don't have very good data there. So this is why this minimum pixel density is very important. And then not too long ago, I personally had the pleasure to attend an event and a presentation of the head of digital development of the city of Belfast. And the lady was pretty clear. She said, you know, with that tremendous speed and the dynamics in analytics software, we can't really plan in the city of Belfast. We see what's there, we test things, we try out things, and nobody can say what is going to be there in a year from now. Nobody can predict what is going to be allowed or not allowed legally. So this is very dynamic, and very simple put, it's probably a good idea to take care of a good data capture element of your analytics system already today, meaning a good and high quality and plannable and predictable video image to be prepared for the analytics in the coming years. And with that, sorry for a 5-minute overrun. I invite everyone to visit our website and then see what we can do for airports, for casinos, for general industry, manufacturing, retail, for logistics, for safe city, and for stadia environments with our system called Panomera Multifocal Sensor Technology. And as I said initially, for those of you who want to spare a few more minutes, we'll happily share a few real sequences. Actually, they are also recorded for obvious reasons, but that will give you an idea of Panomera really in action. So for those of you who have only planned the 25 or 30 minutes, thanks a lot for your attention and your interest in our webinar today. And I wish you a very good rest of the day. And for those of you who can spare another 5 minutes, you're welcome to stay with me and have a look at some real footage out there.